Let's solve questions on this particular topic, which is measurement and units. And now, as we listen, God bless you. He said what? The International Agreed System of Units, SI, for the physical measurement are dash A, pounds, feet, seconds. B, gram, meter, second. C, kg, meter, seconds. D, centimeter, gram, seconds. And this question is number 1978, number 9 question. It says that now, if you want to know international agreed system of units, those are basically what? Fundamental what? Unit. And for example, mass is part of it, which is what? Measured in kilogram. Then we have length measured in meter. Then we have time measured in second. So this one now is what? Kg, meter, second. So the answer to that question should be what? Option C, which is what? Kg for mass, meter for length, and seconds for time. Now the number 2 question says the following are some units. Roman figure 1 is what? Newton seconds. Newton seconds is for impulse. Newton seconds is for impulse. Don't forget, impulse is the same thing as momentum. So Roman figure 2 is Newton meter, which is for work. So Newton meter for work or energy or work or moments, and it can also be used for torque. So Newton seconds is what? Impulse or momentum, as I said before, which is unit for momentum. Roman figure 3, Newton per meter square. Newton per meter square is for pressure, the unit of pressure. Pressure is also be what? For Young modulus. Young modulus. It can also be for stress. Stress is also Newton per meter square. Then Roman figure 4 is joules per Kelvin. Now, joules per Kelvin is what? Unit that shows what? Energy or work over what? Temperature. And that will be what? Specific. Or no, not this one is not specific. This is heat capacity. Because heat capacity is equal to what? Work or energy over change in temperature. Don't forget that energy, which is energy now, let me clear this side. Energy is equal to what? C change in theta, or heat energy equal to change C, capital letter C mean heat capacity, change in temperature. So that is it. Then we have the last one, which is what? Specific capacity. Joules, Roman figure 5 is what? Joules per Kelvin. This one is joules per kilogram. Joules per kilogram is latent heat. Latent heat is equal to what? Energy or heat divided by what? By mass. Don't forget, you forget that what? Heat energy is equal to ml. Heat energy equal to mass times latent heat. So if mass times latent heat give us what? Heat energy. Therefore, latent heat should be what? Energy over mass, which is what? Joules per kilogram. So then I say, what did they say now? They say, what are the units of latent heat? The latent heat is what? Joules per kilogram, which is Roman figure 5, option D. Number 3 says, for which of the underlisted quantities is a derived unit of M? That's number 3. Number 3 now. M L square T minus 2. Now don't forget that mass, the dimension for mass is M. The dimension for length is L. The dimension for time is what? C, capital letter T. So in this question now, M is what? Dimension for mass, which is what? Kg. This one is L square is for meter. Then then T is for time. So this one should be equal to what we call, I'm seeing force times distance here. Force times distance. What is force? Force is what? ML T minus 2. That is force for you. Then dimension for time, for distance is what? L. So L times L is L square. Then ML square ML T minus 2 times L is what? Exactly this. And this force times distance is actually talking about either work, talking about the energy. It's also dimension for moment. It's all the dimension for what? For torque. So 4 of them can hold this dimension, can have this particular dimension rather. So that is option. So that means we have Roman figure 1 is moment of a force. Yes, correct. Roman figure 2 is what? Work, which is correct. Roman figure 3 is acceleration. Then A says 1, B says 1 only, B says 2 only, C says 3 only, and D says 1 and 2 only. So the answer to that question should be what? 1 and what? 2 only, which is Roman figure 1, moment of a force, and work, which is Roman figure 2. Option D is the answer. That means number 4 now says, which of the following is not a fundamental SI unit? Now, there is a shortcut I need to show you here to get our fundamental SI unit. Don't forget, this is meters, a shortcut to remember your fundamental unit, which is mass. M is mass, which is measured in kg, has a dimension of n. We have what? The electric current is your E. Electric current, which has a what? A unit of ampere and dimension of either I or A, depend. Then we have what they call the time. Time is measured in seconds. Time is measured in seconds, and what also have a dimension of what? Capital letter T. We have another temperature there. Temperature is the second one, which is 2T there, and it has a what? It's measured in Kelvin fundamentally. Now, it's also measured in Celsius, but Celsius is not a fundamental SI unit of temperature. So in this case now, what we are going to have now is that we are going to have Kelvin as the fundamental scale, then theta as the what? As the dimension. Sometimes you see K, but theta is common. Now we have what they call amount of substance. Amount of substance is our A. Amount of substance is measured in what they call mole. Amount of substance is measured in mole, and it has what? The dimension of capital letter N. Then we have what they call the length. Length is measured in meter and has a dimension of L. Then we have luminous intensity is the second one. There are two lengths. Is what? Luminous what? Intensity. Measured in what? What is the dimension for luminous intensity? Is what? Let me unit first. It's called candela. Then the dimension is what? A symbol like this, like J kind of. So that is what? The dimension of all this one. So the answer to that question say A, option A is meter, B, ampere, C, Kelvin, and D, radian. So the one that is which of the following is not a fundamental SI unit? The answer to that question is radian. Radian is a mathematical unit, not a what? A fundamental unit. So it's not a part of answer. Option D is answer number 5. Which of these following is a derived what? Unit? Anyone that is not here, all these ones are fundamental examples of what? Fundamental units or quantities, as the case may be. Let me use quantity. Quantity upon which other derived quantities are what? Are formed. So derived unit is a combination of two or more fundamental quantities. So this one now, we say what? Which of the following is a derived unit? A, kilogram, no, that is mass. B, meter, that is length. C, Kelvin, that is temperature. D, Newton, which is force. So the answer, force is not a derived, it's not a fundamental unit, rather it's a derived unit. So option D. Number 6, we say which of the following unit is equivalent to kg meter per second? Kg meter per second is a unit for what? Impulse or momentum. Don't forget the equivalent unit of what? Of impulse, pardon me, sorry for that, is what? Newton. Kg meter per second is a unit for what? Momentum. Momentum, or what we call what? Impulse. So the unit of momentum or impulse is what? Kg meter per second, or which is the same as mass times velocity in terms of formula. So the answer to that question, so which of following equivalent to kg meter per second? The answer is Newton. It's Newton per second. That one is rate of force. No, Newton meter per second. So that one is not the answer. C is a Newton second. Yes, correct. This is joules per second. No, that is not the answer. So the answer is C. Option C is joules Newton second. This is correct. Thank you. We meet in the second section.